Hi, in this question, you're asked to figure out an average bond energy, the average carbon-chlorine bond energy in tetrachloromethane, given a bunch of data. As with all energetics or thermodynamics kind of questions that involve reactions and changes, the key or the base idea would be to figure out the chemical equation that describes the processes that happen, and you have to pay particular attention to the state symbols. So let's work through this problem. You're given a bunch of information. Okay, so you have atomization of carbon right over here. You got the atomization of carbon, which means you're turning carbon solid into carbon gas, right? And we know that's important because when you're trying to figure out bond enthalpies, you really want to make sure that you're looking at just the energy change when an atom connects with another atom, and there's no other influence that could, sway the value. So atomization of chlorine, interestingly, would be to turn chlorine gas into gaseous chlorine atoms. You've noticed that I have written half there because the atomization implies that we're looking at forming 1 mole of chlorine atoms. All right, it wasn't so much of a problem when it was carbon, but here you got to be careful because you got to deal with the fact that chlorine is a diatomic molecule. Now, the formation of liquid tetrachloromethane, I think we can start there. So let's have a look at that. And we need, again, I'm going to revisit this key idea. It's liquid tetrachloromethane, not gaseous, not solid, but liquid. So let's write that out. Formation enthalpies refer to creating a compound from its constituent elements in their standard form or state under standard conditions. So if we look at tetrachloromethane, there's carbon and there's chlorine. So let's write that down. Carbon, that's always in a solid. I only need 1 of that. And I need 2 moles of chlorine gas to get me that 1 mole, that 1 mole of tetrachloromethane in the liquid state, right? And we need to be a little bit careful here because we are asked for the bond formation, and for bond formation to hold true, we need to consider stuff in the gaseous state. And so there might be one other process that needs to be written down. So this will be delta HF of CCl4. I need one more state or one more step here. That will be CCl4 gaseous, and that would be this guy over here, the delta H of vaporization of CCl4. So how do I figure out the CCl bond? Well, it's got to be in here somewhere. So the question is, what can I do? Well, let's look at the information that's given to us. This is the atomization. So let's try that. So I'm just going to write in blue stuff that other information that's given to me. So I have carbon turning into a bunch of atoms. That's 1. So that's the delta H atomization of carbon. And I have 2 moles of chlorine gas, and I sort of have the atomization of chlorine. That's cool. So I need to multiply that number by 4 because I'm forming 4 moles of chlorine atoms. Cool. So I have 4 times the delta H of atomization of chlorine. Right? So easy idea. You're trying to form chlorine. You're trying to form a bunch of chlorine atoms. It makes sense to reference that as the 1 mole of something. So you have 1 mole of chlorine atoms. So And lo and behold, that's the golden bit. You are going to form 4 CCl bonds here. You have a bunch of carbon atoms, you have a bunch of chlorine atoms, put them together in a ratio of 1:4 respectively, and you're going to form 4 CCl bonds. In other words, I could really just write this bit out as delta H, 4 times delta H, the bond energy for the CCl bond. Cool. So now all that's left is to put this in a cycle and we are good to go. Just make sure that we've taken care of all the signs, and we have. So I'm going to write this. Delta H formation of CCl4 liquid. In fact, I should have put that there, right over here. So please mind that. Plus the delta H of vaporization of CCl4 is equal to the delta H atomization of carbon plus 4 times the delta H of atomization of chlorine plus 4 times the delta H, the bond energies of CCl. Just make that the subject of the formula. You have 4 delta H bond energies of CCl. That will be equal to, so let's plug some values in, and give me a second here. The values will be CCl liquid, let's see, minus 139 plus delta H vaporization plus 30 minus delta H atomization of carbon minus 715, and the minus 4 times the atomization of chlorine will be 121. Now, before we do anything, we should ask ourselves, well, of course, there's the kilojoule per mole thing over here. We should ask ourselves if we should expect a negative or positive number. And given the fact, if you look over here, we are forming bonds. Forming bonds, which implies that this bit should be exothermic. So we should expect a negative number over here. Right, so let's plug that number in to a calculator. So minus 139 plus 30 minus 715 minus 4 times 121. And that gives me minus 1308 kilojoules per mole, which means that the CCl bond energy is equal to 1308 kilojoules per mole divided by 4. You've noticed that it's a separate statement altogether, right? I'm going to put a therefore in there just to clarify that. Bond energies are given as positive numbers because we refer to the breaking of those bonds. So that's 327 kilojoules per mole. And well, in an exam situation, you probably want to check this against what's given in your data booklet, and you will realize this is fairly close. All right, that's it.